All right, let's get started. I'm way too impatient to wait. So, today we're going to be working on implementing a DirectX 11 software renderer, or at least the beginnings of one. And so we're going to start with basically getting DirectX 11 set up and drawing something onto the screen. So if we have a look at the documentation over here, there's a whole bunch of pages of things, and I'm not sure exactly what we're going to need, so I've just been reading a couple of these in advance. I think we can start with this step here, which is how to create a device and a swap chain, because a reference device seems to be something used only when you're doing debug applications, and a warp device is some kind of software rasterizer, which is what we want to build, so we probably don't want to use that. So we'll just go off to this step here, how to create a swap chain. Now, I've done a little bit of graphics programming, so I can explain what a swap chain is as we go. Actually, maybe I'll just explain it now. At least my understanding, it might be a little bit, there might be a little bit of information missing, but you can imagine a swap chain, I think, as something like this. If you imagine these squares are pixel buffers and maybe depth buffers, we don't need to go into that, but just imagine this is the pixels that you see on the screen, and you've got a chain of them, and you can start rendering to one of them or any of them, and then when this one, let's say at the front of the queue, is ready, this gets sent to your screen, and then you start drawing to another one while this one is being drawn to your screen. So you can have this double or triple buffering so that you get really smooth looking images. Pretty sure that's what we're about to be making. So we need one of those because we need to draw things. Hi Emma, thank you very much. Emma says have fun. It is all about fun. So, what did we get last time? Last time we got a window up and running. So we've got something like, which one is it? This one. Let me just delete that. Okay, so we've got a window, but we have nothing in the window, it's just white. So we've got to set up DirectX so that we can draw something into the screen. I was considering using Direct Draw, which is an old Windows API, but decided against it. We can just use DirectX and create a texture, and then we can draw pixels to a texture. So you can see here we can create a texture, and then we can just present that texture onto the screen. So that's how we're going to build our software renderer. So we'll start with this, creating a swap chain. So we need to use this function here, create device and swap chain. And we need to fill in this thing, DXGI swap chain description. So this is going to be a struct. It's going to have a bunch of options that we need to tell it what we want. So there's some kind of mode, sample description, what we're going to use the buffer for, the amount, like the count, the output window, whether it's windowed or not. That's interesting. So if you Alt-Enter and you change from window to not windowed, do you have to recreate the swap chain? I've never done that, but I guess you would. Swap chain effect, I don't know what that is, so we're going to have to look at all these options. So, this DXGI mode is a structure that describes the back buffer display mode. Okay, so that's going to be maybe pixel type, width, height, refresh rate, format, scanline ordering. I don't know what that is. Scaling, okay, what's scanline ordering? Describing scanline drawing mode. Okay. Oh, right. Progressive. I think we only use progressive these days. There used to be interleaved, which was, you know, you'd have like 1080i and you would have like every other line being drawn. But we don't really do that these days. Everything is P, so progressive, I think. Someone says hello, missing says hello. Hello, missing. How are you? Alright, so if we... Okay, so we'll start by making this struct. It's a DXGI mode. We should probably also import the header. I don't know what the header is that we need. Is it going to say anywhere? How to create device and immediate context. Is that DirectX 11? Ah, right. So you can see how to make it right here. Well, that's handy. If you request a DirectX 11 device on a computer with only DirectX 11.1 with only DirectX 11.0, then this will immediately exit with invalid argument. To safely request all possible feature levels, use this code. Right. That's fine. We'll just use the latest DirectX 11.1 because it doesn't matter right now. Let's see. Actually, I wonder what the oldest computer is that supports DirectX 11.1. Supported, would it be graphics cards or CPUs or both? There was a website for this. I can't remember what it's called. That's alright, I'll look it up another time. Alright, let's have a look. So this is our description. I suppose we will copy this. So we're going to put in here, we've created our window, we've shown our window. Now we can show the window before or after we set up the DirectX context, or whatever it's called. So, DXGI, no, yeah, it's not available because we don't have the header. How to use DirectX 11. Very good. Doesn't tell me the header names. It's probably DXGI and D3D11. There we go. Oh, interesting. There's underscore 1, 2, 3, and 4. Huh. Wait, what's this one then? Do I need this? Yeah, I do. I'm pretty sure. It's got all the the enums and stuff that we need. Alright. So, what are we missing? Window. Of course, this is not correct. It's going to be window width and window height. So we're going to make a buffer that's window width, window height, and it's going to be DXGI format R8, G8, B8, A8. So 32-bit buffer. That's good. Will you run it to a pixel buffer and render that as a texture? Yeah, that's the idea. I haven't written a software renderer before, so it's going to be interesting to see if we can get something working. But yeah, that was my thinking. We'll just render to a to a buffer, upload that to a texture, display the texture on a quad that's on the screen. I think that's probably going to be the easiest way. I didn't need to change that. Doesn't really matter. So, windowed is true. That is true. We've got a count of 1. Quality is 0. What does that mean? Let's have a look. So sample description, which is this. Quality. The higher the quality, the lower the performance. The valid range is between 0 and 1, less than the level returned by quality levels. Hello, Sharuk. I hope I pronounced that correctly. DX11 is not like Vulkan. It's more like... It's a similar level of abstraction to OpenGL, but it gives you a little bit more control and it has multi-threading, whereas OpenGL doesn't. DirectX 12 is more like Vulkan. So DirectX 11, you might see that we have to create a swap chain, but that's about the only thing that's similar to Vulkan. It does have things like, I believe it has fences, it has compute shaders. I'm not sure how you make semaphores, but I'm pretty sure there are those things. So yeah, it's kind of like in between, I would say in between OpenGL and Vulkan in terms of the abstraction level and capability. But I'm not an expert. That's just my, from reading and from a little bit of experimentation, that's just the sense that I get. What was I reading? So quality levels. What does this mean? It just says the image quality level. Okay. I don't think we need to worry about that because we're not going to be doing upscaling or downscaling on this at all. So we'll just leave it at 0. Output window correct. Render target output. Okay, so let's see what this is. The buffer usage. I want to learn about that. Describes the surface usage and CPU access options for the back buffer. Right, okay. So we're using this as a render target output. I see. Oops. Does that mean we can... we'll just continue with this first and I'll figure it out as we go. So we need to create our device in our swap chain, which is going to be this call here. D3D 11 create device and swap chain. Alright, so we need a lot of stuff here. We need an adapter. Where do we get an adapter from? Apparently we don't need an adapter. Well, let's have a look at that. An adapter is a pointer to a video adapter. Pass null to use the default adapter, which is the first adapter enumerated by this. Okay, but what is it? Video card. Okay, right. So this is how you would select a video card, which means you can do... Yeah, but you don't have to. So in Vulkan, when you're creating your swap chain and all that kind of stuff, you have to manually query the GPUs and then check their properties and see if they can do the things that you want, and then select one and then use that one. So with DirectX 11, it kind of does it for you if you pass null here, which is nice. You can use libraries like VK Bootstrap, Vulkan Bootstrap, which will do it for you. So it'll provide a similar functionality. I haven't used that myself though, but I just know about it from reading. So yeah, we pass null and then well, we need a driver type. What is this? So driver type, unknown, hardware, reference, null, software, or warp. So we're creating a software renderer, but I don't think we want to use a software driver. Maybe we do. Is it technically a software renderer if you still use the GPU? Don't know. So warp driver is a high performance software rasterizer, which is kind of what I was alluding to earlier. I don't think we want to use this because we want to make something like this, I think. Well, we're just going to go with hardware. And we're going to draw to a texture and we're going to render the texture. So it's going to be not a full software renderer, I guess. It's kind of cheating, but that's fine. So we'll say hardware, yes. D3D driver type hardware. Okay, so this is some kind of pointer to something called software. What is that? Where is it? Wrong thing. Handle to a DLL that implements the software rasterizer. Okay, so this is going to be null. Then we need some kind of flags here. Layers. So create device flags. Let's have a look. Runtime layers. What are layers? Layers start basic functionality and okay. They add functionality but do not modify existing behavior. Alright. I see. So this would be similar to in Vulkan you can use layers. You can add a debug layer which will give you really nice output messages. So these ones seem to come with DirectX 11, and then you can create your own layer if you want to. We're not going to do that, but we'll add the debug layer, I suppose. I have the DirectX SDK installed, I'm pretty sure. So we need D3D11 create device debug flag. Okay. Oh, I was looking at that page here. So, single-threaded, no, we don't want single-threaded. We want debug, so we use 2, and then what's BGRA support? Oh, that's right. Where is it? BGRA support, did I miss it? There it is. Yeah. We've got red, green, blue, but not blue, green, red. I don't want to use blue, green, red. Okay. Maybe we don't need this. So we'll just add the flag 2 and okay, device debuggable, that seems pretty useful. You must have this DLL installed. Well, I guess we'll find out. Do I have this DLL installed? Apparently. Yes. I don't know if that will be accessible in my program. Oh, this value is not supported until Direct3D 11.1. So we have to include, we have to change the version to 11.1. Where was that version? Oh, here, the feature level. Okay. All right. So we want this flag. Did you see how slow that pastes, by the way? That's something I really hate about the terminal emulator in Windows. Look at that. Look how slow that is. If I copy a bunch of stuff, it has a bug. So if I copy this, paste it with Control V, it's gonna type out every character, and then it's gonna create extra braces as it goes, and everything's gonna get all whack. Look at that. Isn't that just disgusting? Anyway. So, no, we didn't want BGRA support. We wanted device debuggable. Create device. Okay, you're not gonna give me the autocomplete. We wanted, what was it, debug? Yes. So the feature levels, let's have a look at this. Okay, so we've got a type called D3D feature level. Feature levels requested equals blah. Oh, it's D3D feature level, of course, not 11. This is an interface. So we want 11.1. There we go. And we pass this in by pointer for some reason. Okay. Feature level. And how many feature levels we got back? I guess num feature levels requested is 1. Feature levels supported. Okay, that's at the end there. All right, let's see. So I've got feature level, SDK version, D3D11. Whoa. Sorry about that. D3D11. It's not feature level 11. D3D11 SDK version. Yeah. So our swap chain description is SD DXGI swap chain. We did not make that, so we will here. Device, did we create a device? No, we need to define a device. Is it this? I think it is. IDXGI device. No, ID311 device. Apparently not. ID3D11 device. Good. What's next? Feature level supported. Yep. And immediate context. What is that? Okay. Feature level supported. Immediate context. All right, let's look that up. I don't know what that is. Wrong page again. Here we go. So the swap chain is the swap chain object. The device is the device object. Yada, yada, yada. Okay. The address to an object that represents the device context. If this pointer is null, no context will be returned. But what is this? A device context which generates rendering commands. Okay. I suppose we probably need one of these so that we can start writing commands. What is the type? Device context. No, this is incorrect. Oh. I feel like maybe we needed to make a device. But let's see what this returns, eh? So this should return an H result. Just going to put this in its own scope so we can not worry about clobbering variables. And let's have a look here what the result might be. I'll also just set a variable here so that it doesn't exit the scope. Let's have a look. What do we get? So, unresolved external symbol, create device and swap chain, because we're not linking DirectX11 in our build file, so I probably need to add, I don't know what we need to add, DX, I don't know what the library is called. .lib. D3D11, yeah, there it is. Cool. Okay, that works. And we got to our point, and we got a result, which is this number. What does that mean? Two, 2, 8, 9. Well, what's it supposed to return? Where is it? Create device and swap chain is supposed to return. It can return a return code. Okay. Right, so I think we got an error here. Let's put this in hex and copy this. Okay, apparently we didn't get an error. At least not one that's in here. That's not great. WSBAPP. What does that mean? Well, what is the swap chain? Swap chain is null, device is null, device context is null. So this definitely didn't work. Okay, let's just have a look at what we wrote and what they wrote. So, null, hardware, null. Okay, they put 0 for the flag, so I'm just going to try 0 for now. Feature level, D3D11 0. I put 11 1. I'll try 11 0 for now. Number of features request, yeah, 1. That's fine. D311 SDK version, okay. Swap chain description. Okay. Global pointer to a swap chain, global pointer to a D3D device. That's what we've got. Swap chain. It is an IXDGI swap chain, right? I mean, this would be a bug if it wasn't correct. That'd be a warning at least. Okay, feature level supported. Great, and device context is global pointer to immediate context. Okay. This topic shows how to initialize a device. Okay. Oh, sorry about that. Each application must have at least one device. Okay, that's good. Device context. Used to set pipeline state and generate rendering commands, so we need one of those for sure. An immediate context. Renders directly to the driver. Each device has one and only one immediate context, which can retrieve data from the GPU. Okay, interesting. Deferred context. Oh, so this would be like a command buffer? Or just, yeah, runs commands at the end. Great. Okay, that's fine. Well, we didn't change anything, and I'm going to run the code again, and then nothing is going to be different. But sometimes I just do that. Oh look, it worked. Okay, so we did actually change something. We changed the version, we changed the flags. So it was one of these two. Let's have a look. If we change the feature level, what happens? We get success. If we change the flags, it's going to be the flags then. And we get some kind of error that is not obvious. So let's see what happens if we just add one flag in here. Create device debug. That one worked. This one doesn't work. Let's reread what that said. Create device debuggable. Causes the device and driver to keep information that you can use for shader debugging. The exact impact, yada yada yada. Okay, I'm guessing that it can't find this DLL. Yeah. So, if I find this DLL on my computer, which is SDK. Okay, so D3D11, wasn't it? _1 SDK layers.dll. If I open this and I copy it to here, what happens? Can we use the flags then? No. Oh, maybe I need to copy it to the build directory. What's the working directory here? Yeah, the working directory needs to be set there, and still no. Okay. Maybe I need to load it, but I'm just gonna instead remove the flag for now. And we'll just get on without it. It says to install the Windows 8 SDK to get it. Yeah, but I have the DLL, so I'm pretty sure I would have the Windows SDK installed. Okay, cool. Also, how you doing, Daniel? Okay, so I've got a device. We'll worry about whether we need to add that debuggable flag later. Now, we don't want to enumerate adapters. Interesting. So create a device and immediate context. This is what we just did. Daniel says, been down this road. Also, he's not bad. He's been down this road many years back. Wasn't fun and didn't go far. Oh, that's fair. All right, so we've got a device and a swap chain. We need to be able to present the swap chain. I know that's a function, isn't it? Present swap chain. Is that what it's called? Yep. No, it's just called present. DXGI swap chain. Okay, so that means we would have on our swap chain a long pointer v table present. So at some point we need to call this internal interval. I don't know what that is yet, and I don't know what that is yet. So we need to call this in our loop down here, which means we need to move this stuff out of here. So we probably need access to these things at some point. But I'm pretty sure we need to do a bunch of other things before we just present the swap chain. So if we run this, yeah, we get a bug. Oh no, that's the interrupt. Oh, we got a black buffer now. Interesting. Maybe it did just work. Huh. Okay. So let's have a look. We've created a swap chain. We want to create a texture and render the texture. But first, is there some kind of clear screen color? Let's see what's on the feed table here. Okay, nothing that we want to use right now. Get buffer. What does that do? Let's have a look. Where's the swap chain thing I was just looking at? I probably closed it. Oh, that's right. I'm never going to get used to this. When you press enter on this website, it doesn't submit the search. You have to click this button. Why? Why? What is all of this stuff? Okay. Great. Just going to use Google. Okay, great, awesome. So what was this get buffer method? What does this do? Accesses one of the swap chain's back buffers. Interesting. So if we can directly access the back buffer, write data to it, and present it to the screen, then that's what we wanted to do, right? But what is this? What's a PP surface? I need to know what a PP surface is. It's a back buffer interface. All right, that's good. Why don't we just have a look at it? So we're gonna grab it, swap chain. We're gonna get the buffer. But how do we know which one? So 0 based buffer index. Okay, if the swap chain's effect is discard, this method can only access the first situation. What? It's the first buffer, that's fine. If it's sequential or effect flip, sequential can be read from and written to. Only the 0 index buffer. We're just going to use 0 anyway. Okay, we're going to use 0. What is the second parameter? The type of interface used to manipulate the buffer. What? Okay, I need to find out what this is. I don't know why there's not a link here. Is this going to actually find it? No, of course not. REFIID. Oh, it's a unique identifier. Is that right? Okay. So the type of interface. Type of interface. I don't know. I'm gonna pass null and see what happens. But it's a uint, so oh yeah, buffer 0, null, and then a pointer to a PP surface. Okay. I don't know if I can do this. Let's have a look. The first arg is swap. Oh yeah, sorry, you're right. Swap chain, yeah. Daniel said first argument is swap chain. Yeah, he says it's the C version of a virtual function. That's right. Long pointed to a V table is what this stands for. Okay, what did we just get to? What just happened? Where are we? Okay, we got a trap. Yeah. Well, we can't write to this, right? Hang on, what is the problem here? Did I not compile this? I did. Exception thrown somewhere that I can't see. Okay, yeah, that's correct. Debug break. Good. This is just a bit off. So this is null. Okay. Pointer to a void pointer. Yeah, that's what I needed. Let's see. Returns an error maybe. Right, let's have a look. Something weird is happening. Okay, yeah. I'm doing something stupid here. What's the problem? Is it that I can't write an address into this void pointer for some reason? Isn't that what this would do? It shouldn't be a problem. I'm just declaring a pointer. Maybe it needs to be initialized. Oh yeah, maybe. What is this? It's trying to move into R8. Dword pointer. No, comparing. What's in R8? I need to learn assembly better. Okay. First argument. First argument? Daniel says first argument. You mean the swap chain? That is a pointer to a swap chain. Oh, RCX, RDX, R8, R9. Third argument. Right, so we are going to need whatever this argument is here, I guess. Where was it? Get buffer. The REF IID. The type of interface. Yeah. I guess not. Okay, I'm just gonna have to cheat and look this up. Oh god. Stack Overflow. Oh, I remember these things now. Yeah. Okay. There's some, what are they called? It's like texture UUID or something. Yeah, how do I find it? D3D11 texture 2D UUID, something like this. Not this one. Okay, let's have a look here. What does this say? UUID of resource. Okay, I think it's this. ID 311 texture 2D. Except it's got a different name. It's called... What is it called? Okay, I'm gonna have to look up something. Samurai D3D11. So this is actually really cool gist, or gist if you haven't seen it. It's D7 Samurai minimal D3D11. And it's written in C as well, isn't it? Or is it C++? Oh, it's C++, so I might have the same problem. Yeah, it's very clean. Just straight code, nothing to worry about. It's good. That's what it is. IID. Isn't it? No? This one. IID. ID 3D11 texture 2D. Is that right? And this is incompatible because it needs to be a pointer. Unresolved external symbol, because this was in D3D11. Something is missing. Do I need DXGI? No, apparently not. Okay, let's have a look. Where is this? What? Didn't I just copy this? D3D11.h. That's the header. So the problem is we're missing the external symbol. Why? Need to link something. Oh, I should just look at that D7 Samurai thing again. He's got the pragmas at the top here. D3D11, D3D compiler, and user 32. So I'm already linking D3D11 and user 32. Is it D3D compiler? Compiler. No, apparently not. You can define your own GUID instead of linking it, says Daniel. Really? That's weird. Okay, he's sent some code in here. Let's have a look. Where did you get this from? What is this? Okay, this doesn't really help. I want to see what the actual error is. Oops. Alright. Oh yeah, can I not copy this? Fine. Unresolved external symbol. Let's have a look. DXGUID.lib. Well, okay. Let's see. Okay, that's the problem, but what is that? Oh, DX global unique identifiers. That's weird. I wonder why it's a library. Maybe you don't need it for some things. Okay, well thank you for telling me about this. But the actual solution, well, the official solution, I guess, would be to link this library. Although if you only ever need a subset, I suppose you could look into the library and use the values directly like this. Okay, let's see. What did we get? Did we get something that we wanted? We got a result. We got OK. Okay, and we got a PP surface here. Daniel says, to be honest, he doesn't know if that's the correct UUID, and he thinks you'd probably want to link the library, but you can try the UUID. Yeah, I mean, we could look at what it is, right? It would be, it's available here. So if we have a look at this, and we put this in hex, that looks, sorry. Yeah, that looks like the same thing. And then if we also put this, what is this? Data 4, if we make that hex as well. Okay, apparently it doesn't want to be hex. I think we need to make it an array. Array in hex. Yeah, 09A. Oops, sorry. 09. Yeah. 03E. Okay, that's incorrect, I think. But it's close. Interesting. So I guess you could use this directly if you wanted to, and then you could save. Daniel says he asked GPT to turn UUID of thingy into C. Right, gotcha. Well, it was pretty close. Pretty close. Alright. So we've got our PP surface now. I'm never gonna get tired of saying that. It's great. And what is this? What is the PP surface? Well, let's have a look. We'll go to the memory location. Not that. This is the wrong place. This is on the stack, right? Yeah, this is the... No. No, this is the heap. No, it's the stack. Oh, I'm confused now. Oops, open render doc by accident. Well, what is this? So this is an address. Is that... Okay, I think it's an address. Well, it could be anything. I don't know. This is telling us this is a D3, D11 texture 2D1. So I guess this is an ID or something. Perhaps these two rows are an ID identifier of some kind. This is the type, I guess. I don't know. PP surface implies a double pointer, so the first layer would be another address. Yeah. But the reason I'm confused about whether this is the stack or the heap is because usually when you're on the stack, so if I go to this address, flags, right? Oh, I can't. Result, perhaps, yeah, result. Just give me a second. Hey, give me the address. Wrong button, there we go. Yeah, see, this is the stack, because you can see all the stack variables here, and etc. So that was the heap. So interesting. I just don't know what all this data means, though. So I need to find out about this PP surface. What is inside there? What's the structure? It's because you probably only have a temporary context or handle of the back buffer. Yeah, so it could be that the P surface is on their stack and you filled a PP surface with the address of it. I see. Yeah, so I'm probably going to have to use their functions to interact with the buffer. And this address is not going to be just a buffer of pixels, I'm guessing. So that would be too easy. So what can I do with it? I can look up IXDGI buffer, I'm guessing. Is that a type? Apparently not. Okay. Well, so we can access a back buffer, but what can we do with it? Let's see. 1 second. Alright, let's have a look. I'm asking the AI. So, after we get a buffer using getBuffer, storing it in a pointer, often called PP surface, there are several key operations that we can perform. We can map or unmap. Okay, interesting. We can bind it to the pipeline as different type of buffer. We can copy data between the buffers. We can update buffer contents. Right, so we need to use this context that we created earlier. So context controls everything to do with the buffer. So if we want to update the contents, we would use update sub-resource. Okay, and then we pass in new data. Okay, let's have a look. So, I don't know how I was supposed to infer that, but let's see what we can do. Context. Do I not have a context? Oh, device context. Device context, long pointer, and then update sub-resource. So we can pass in our context. Our destination resource is going to be the buffer. Why is there a number here? Okay, let's look up this update sub-resource. And we don't want the DX11 one, we want the DX12, sorry, we want the DX11 one, not the DX12 one. Here we go. The CPU copies data from memory to a sub-resource created in non-mappable memory. Okay. So, destination resource, 0 base index, so probably going to be 0 for our purposes. A pointer to the box that defines the portion of the destination sub-resource to copy the pointer resource data into coordinates or in bytes for buffers and in texels for textures. If null, it's written with no offset. Okay, an empty box results in a no op. A box is empty if the top value is greater than or equal to the bottom value. Oh, I see. So this would allow us to update regions of a 2D or maybe even a 3D buffer. Yeah, 3D looks like. Interesting. I pointed to the source data in memory, the size of one row of the data, and the size of one depth slice. What the hell does that mean? A depth slice? Is it going to be 1 or is it going to be 32 bits? Well, there's some remarks here. Let's have a look. A resource cannot be used as a destination if the resource is created with immutable or dynamic usage. Okay. Right, okay, explains here. To better understand the source row pitch and source depth pitch parameters, the following illustration shows a 3D volume texture. If the resource is R32, G32, B32, A32, the size of each element would be 128 bits, or 16 bytes. I see. So we're using R8, G8, B8, A8, which means 32 bits, 4 bytes. Okay. Well, let's just see if we can do anything to this. So, we don't need a box if we're going to update the whole thing, but we do need some kind of data, which we'll call new data, and then we need, wait, what? Right. I don't know what I'm going to make this, maybe just an array. Why is it complaining? Because it doesn't exist, I guess. So, pixel data, we'll make an array of bytes. That will be fine. Source row pitch. Okay, I need to read this again because my memory is like goldfish. So, source row pitch is the size of one element in bytes times the number of elements in one row. I see. So that would be size of one element in bytes. Okay, which would be 4 bytes times the number of elements in one row is the width of the screen. So 4 times window width. And the depth is going to be the source row pitch times the number of rows, which is the height. Right, okay. 4 times window width times the height. That seems a bit strange. Well, that's what they say. In this case, 3 volume texture where the size of each element is 16 bytes. The formula is as below. Right, because it's 3 rows. Okay. Okay, we need to actually put some data in here. So what are we going to do? We're going to make an array of U8s, and it's going to be window width times window height times 4. Why is this not? Did I not include this? Macros.h. There we go. No? That's very strange. Why is it not working? Undeclared identifier make. Well, it's not undeclared. Not enough arguments. Oh yeah, I didn't pass in an allocator. There we go. I was just being silly. Great. So I've made some data, and let's just fill it with red. No, that's not going to work. We can't just mem set it red. But if we mem set it to 255, then maybe we'll get white again. Let's see what happens. Well, we got a bug of some kind. Let's see. Okay. Maybe this allocator is not big enough. Did this come back null? Yeah. We need to make the allocators larger because they're only 124 bytes, and that's not going to be large enough. Let's make them okay, I need a macro called kilobyte, and we're gonna have an X, and then we're gonna make it 1024 long, no, unsigned, long times X. Pretty sure I don't have to do this again because it'll be defined here, but I'm going to do it anyway just in case. Daniel says, I think you have to call backbuffer get description, backbuffer description to get the description of the backbuffer size, like width and height of it. Oh, okay. That might be useful then. Let's have a look. Before we do that, but we don't have the back buffer. We have a PP surface. Alright, that should do for now. So kilobytes and megabytes. We don't need gigabytes. We're not about that. We'll just make our allocator 16 megabytes, and then we should be able to allocate enough space for this. And we've got a white screen again. That's a good sign, right? But why did we get... Oh yeah, there's a debug break here. So does that mean we just wrote white pixels into this? Maybe. What if we make these gray? No. That doesn't work. No, I don't think we actually got anything working. If I remove this, we still have a white screen. That's... Oh, because I'm breaking here. I'm really stupid. What about now? Gray. Okay, yeah, this works. So this is actually pixel data. Yeah, updating sub-resource straight into the PP. Sorry, not into the PP surface. Using the PP surface. So, if this is pixel data, we can write pixels to the screen without using a texture. We can just use the back buffer directly, which is great to get started with software rendering. So, if we want to make a renderer, we probably want to make some minimal abstraction, which could just be a bunch of functions. So we have perhaps a struct, which would have some pointers to things that we'd need to use, and then functions to call to draw things to the screen. But let's just see if we can get, for example, drawing a rectangle, a solid colored rectangle to the screen. How would we do that? Well, I think we can actually use this function here and this parameter here, which we've set to null, which would be a box, and update part of the screen. Or we could just always write into a big pixel buffer, which would be here, and then we just display that every frame. Either one I think would work. Yeah, I guess we should just use our own pixel buffer, because then we can be agnostic about how that pixel buffer gets displayed to the screen. So basically we want to make some kind of renderer code. Let's call it, why are names so difficult? I would usually call it renderer.h or renderer.c. I'll call it software renderer. Or blitter, software buffer, buffer drawing, push the buffers, yeah, who cares? Doesn't really matter. We'll just do our usual include guards here, and if, and software renderer included. So let's design an API first. That's what I like doing anyway. So if we're going to draw to the screen, we probably want something like draw rectangle, draw, well, not square, circle, draw line, draw triangle, etc., etc. Draw text. So we want something like this. So why don't we just take these, put them here, and figure out how they're going to work. I don't know why I made them ints. It's just because that would be ints by default. So if we got something like this, well, we need to know who's drawing, I guess. So maybe we have a draw begin, a draw end. So this can set up some kind of internal state so that our renderer knows, oh hey, in between the draw begin and the draw end, when we issue draw commands, it's going to whatever we specified in draw begin. So we could say something like draw begin and then pass in a pixel buffer. Maybe. It's just spitballing here. Do something like this. So we do something with the pixels. Maybe we don't have to do anything. Maybe all it does is internally sets up, hey, our pixels are going to be pixels, whatever. Yeah, I think that's fine. I don't want to pass in state with every draw command. I'd rather just have it sort of like an opaque state machine thing. Let me think about it. So what I'm tossing up between is, do I just put some state here? Maybe make it static, although I don't think that really matters because everything is one translation unit anyway. So there is no file private state. But let's say we have some state here and then we just update this is our buffer, and then when we draw, we do something with the buffer, etc., etc. Or do we create an instance of a software renderer and pass it in to all of these functions here as the first argument. And then it knows which one we're talking about because we pass it in explicitly, or do we make it implicit? Are we ever going to have more than one software renderer running at once? I don't think so. So I'm probably going to go with the local state version, and then if we want to refactor it later, we can do that. So I'm just going to say here, software renderer buffer is nil. Daniel says, draw begin should receive the buffer of color to write into, and then all the APIs just affect that. Draw end clears the internal pointer. Yeah, that's basically what I was going to do here. So software renderer buffer equals nil. That way, if you try to call one of these functions outside of these two, you're going to get an error because you'll try to write to a null pointer. So we want to draw a rectangle. So how do we draw a rectangle? Well, we just have to define a position for the rectangle. How do we want to define rectangles in this engine? There's two ways, well, three ways. There's a couple ways. The way that Raylib does it is a rectangle is x and y, width and height. I really hate that bug. Okay, the way that some other things do it, especially physics libraries, might use min and max, where they're vector 2s. And sometimes you might even see center and half size or size. And you could also, yeah, so min is basically the same as xy. You could also do x, y, zw, or PQ, whatever, so this would be top left and bottom right. Yeah, Daniel just said that. The ugly cousin windows. Top left, bottom right. So that's the same as this one, basically. Which one do we want to use? Well, I've been using Raylib a lot, so I'm tempted to use this one. I think we'll just go with the first one, x, y, width, and height. Why not? So in our case, we're going to say x and y is the top left corner. That's what I'm used to. So I'm just going to stick with that. X, y, top left, and then width, height. Okay, so when we draw a rectangle, well, how are we going to draw it? We could just pass in these parameters as float32s. Or we could have something like draw rectangle V. I'm just copying Raylib convention here, which would give us perhaps vec2, position, vec2, size. Oh yeah, I'm just used to using floating point numbers. Daniel says, why floating point numbers if it's just pixels? It can only be integer indices. You're right. You're right. I'm just used to using floating point numbers. But, that's interesting. Yeah, I suppose when we do more. If we get into 3D stuff, we're going to have to use floating points and then probably convert those in a software rasterization step into integer positions, which would then pass into these functions. So yes, we're going to use integers here. And perhaps they should be unsigned integers because they can't be negative. Daniel says, floats are harder on the CPU, induce more assembly, and on embedded are very bad. Well, that's okay. I mean, it's not okay, but I want to show you something here, which is we are assuming x64 target and the Microsoft compiler, no standard library. So we don't have to worry about embedded. But yes, I agree. We should use integers in this case because we're not doing GPU drawing. So we want to draw a rectangle. How do we do that? Oh yeah, you might be confused about that because I use memset here, but memset is actually an intrinsic in the Microsoft compiler, so this one doesn't work. These two work as intrinsics, so I didn't have to write my own versions. Alright, if we can get a rectangle drawing on the screen, I'll be very happy. Very happy. So this is what we got, device context. So when we begin our drawing, we should probably set a device context. Or, yeah, I think we should. Yeah. Should we abstract this? No. Let's not do premature abstraction. Let's just use DirectX directly. It's direct after all. What? Okay. You want to be like that? Fine. Which header was this in? This one? It's the other one, isn't it? Oh no, this one. Yeah, okay. Yeah, pasting the parameter is a little bit too painful just then, but it happens sometimes. Oh yes, we don't have our PP surface, so when we begin, we should probably get that. We don't have a swap chain. Oh man, we need so many things. Well, that's okay. Daniel says, I think you have to let go of the PP surface when you're done with it. This is kind of a joke, but I also vaguely recall having to call release on the P surface. Oh, okay. Alright, we've got some really wide code here. Really wide code. Software renderer device context, software renderer buffer, software renderer PP surface. All very good. So this buffer, actually we need to allocate this at init time. So maybe, yeah, maybe we set the context and the swap chain and the pixel buffer at init. Oh no, we're supposed to pass this in. What am I doing? Yeah, never mind. I'm being silly. Never mind about that. Alright, device context. Okay, I can probably just remove this. And window width and window height we don't have access to, but I was going to make those globals anyway, so why don't we do that. And I'll put them up here. And fix the bugs that we just created. Okay, I've got some warnings. All these are not included. Let's just delete those then, I guess, for now. Daniel says it was enjoyable, but it's got to run. No problem. Thanks for the help, and have a great day. Device context. No, that's incorrect. Software. Renderer. PP surface. He says he learned some things and wants to pull out his old game engine now. Yeah, do it. It's pretty fun. Alright, see you next time, Daniel. Take care. Yeah, right, these variables cannot be here. They must be in... I haven't made a common. I guess I should make a common. Should it be a header file or a C file? And who knows? Okay, great. If I include those in here, then I can delete this and this, and just have common.h. There we go. And we go back to the renderer, we include common instead of these two. We get access to window width and window height, very good. Wow. Well, this shouldn't be here actually, this should be in draw end. When we draw a rectangle, we want to get the x position, the y position, the width, and the height. Okay. Let's think about this. By drawing really messy drawings. So, give me the pen, there we go. So we've got our buffer, which is actually a really long 1D array. Whoop. Of bytes, let's just say our buffer is this big, which is really small. Okay, now we've got pixels. So these are pixels, which means there would be 4 bytes. Red, green, blue, and alpha. So that means we've got 4, 8, 16, 20. Wait. No, I'm being silly. 4, 8, 12, 16, 20. Okay. 20 bytes across. Which means if we want to draw, for example, a rectangle that starts here, which would be position pixel 1, 1. That would be 0, 0. This would be 1, 1. Then we'd have to go across 1 on the x-axis. So it would be from here, we'd say plus 1, or plus 4 bytes. And then plus however long a row is, which in our case is 20. So it would be 4 times width to get to here. But it would be not 4 times width, it would be 1 times, oh no, it would be 4 plus 1 times 4 plus width. So if we, let me make these lines a bit thinner, a different color. So if we wanted to go down here, for example, down to the green one, then we would start here at 0, 0. We'd say move across by 1, or we could move down by 3, either way. So we start at 0, 0. This is 1, 2. That's our goal. So we say plus 2 times bytes on the x-axis, which is 20. So that puts us here. And then plus 1 times just however many bytes a pixel is, which is 4, which would put us here. Okay. Fantastic. So that means we need to get the indices. So the indices would be, okay, let me write this down again. So that gives us the starting position. But then when we write, let's say we're making a 2 by 2 rectangle in here, we'd need a stride. So we can skip these pixels and go straight down to here after we draw this one. So we need an algorithm that will start us here, fill this in, skip these 3, then draw this, and then it's finished. Okay, it would help if I was not underslept. But I'm sure this won't be too hard. Alright, so we start at position 0. We add y times size of a byte times 4, because that's the depth, the pixel, the amount of bytes in 1 pixel. So this would be our starting row. So I guess we could call this row, and then column is going to be x times size of u8. But then when we index into a 1D array, we need to say pixels. Oh, let me think about this. That's why I drew this one over here. Okay, so we're indexing into here, right? So that means we need to go 1, 2, 3, 4, 5. Bloody hell. Okay, so 5, 10, 16. It's not even visible here. So we want to start here, basically. That's fine. So we'd start at, I think it's going to be row plus column. All right, let's try this. It's not called pixels, it's called that. Software renderer buffer. Okay, apparently I'm not allowed to. What's the problem? Oh, I didn't take the address. There we go. So we've got a position. Let's try this first. Let's try making this a red pixel. So we'd say position 0 equals 255. 1, 2, and 3, and then these would be 0. Now we should get a red pixel wherever we try to draw a rectangle, I think. Of course, we've got to make sure all the other stuff works. So let's do this. Draw begin. Draw end. We need to pass in device context, swap chain, and our pixels, which is called new data. I'm going to rename that. And draw end apparently doesn't need anything. I think that's right, yeah. Okay, draw a rectangle, and we'll draw a rectangle at 1, 1, 1, 1. That'll be fine. Apparently it's running, but we don't have a window. That's interesting. Okay, now we have a window, but we have an error. Exception thrown. What's the exception though? I'm gonna run this in the command line to see if we get anything. Nope. Okay. All right. Let's see. All right. Software render device context is never actually set, so of course that's going to be a bug. Hang on, we don't need the swap chain, do we? Oh, we only need it for this function. Okay, that's fine. There we go. All right. I think I see something up there. Maybe I'm just imagining it. Oh yeah, look. Okay, it's definitely wrong, but we got something. So there's a green pixel and a red pixel next to each other. All right, that's interesting. So this calculation is incorrect. We need to do, yeah, this, of course this isn't going to work. We don't use the the width of the screen at any point. So we need to say this is going to be y times size of u times window width, I think. Wait, did that build? Apparently. Okay. What is happening? Sometimes when I run it, it doesn't run. That's not a good sign. Oh, it's not exiting properly. I think it might be what Daniel was alluding to, where you've got to release the buffer or the PP surface. So if I look at the task manager, do I have debug open? No. Well, that's fine. All right. So this is still incorrect. Let's see. Y times, well, size of U8, correct? Yeah. Oh yeah. What am I doing? I don't need to do that. So y times 4, and then x is x times 4, because that's the size. There we go. Look at that. We're drawing a little red dot there. Awesome. Now all we need to do is make this into a loop that iterates correctly. So we'd say for, I guess, the row count. Yeah. So I is less than row. No, I is less than height. I plus equals 1. Maybe I should be row. No, it's fine. We use 0. J is equal to 0. J is less than width. And J plus equals 1. So this is our inner loop where we're going to draw the color. I realize we don't have a color parameter in our rectangle drawing function, but we can add that later. Let's get rid of this. And we'll say software renderer buffer. Or we could just say, yeah, we could draw this, I guess. And then we increment the position by 4. Okay, and then in here we increment the position by 4 times window width. I think that's going to work. Oh. It did not work. Interesting. Oh, yeah, hang on. Our drawing function is a size of 1, so yeah. Let's make it 100 by 100. Or 100 by 300. Okay, definitely wrong. That's fine. What is the problem? We want to increase the column by 1. And then here we want to increase the row by 1, but that's not going to work. You can't just increase the row by 1 like that. That's fine. So we got the starting position correct, but we messed up this. Let's see. So we're increasing the position by 1 row. Okay, what if we delete that? What does that do? That just draws a straight line. So that's correct, I think. Oh, that's pretty long though. Hmm, 291 pixels long. That seems weird. Oh no, sorry. It's, yeah, 291 pixels long. What the hell? Okay. I'm probably making a really dumb mistake here. So this correctly goes to the next row. That's why it's drawing a straight line down. That's awesome. This, however, does not work. Why? 4, we're moving 4 bytes. Oh, we need to move, yeah, 4 bytes, that's right. What's happening up here? Okay, so we're going across. Oh, we didn't reset the X position to 0. Okay, why don't we do it a different way? We'll use, just to make my brain a bit less fried. Yeah, we'll use row and column. Okay. Then we'll no. We won't multiply by 4. We'll do this. Okay, let's just make sure that works. Yeah, that's the same. And then we will increment the row, and here we'll increment the column, and here we will set the position, oops, to this, get rid of that, get rid of this. Okay, is that? Alright, that's not what we wanted either. Because the column doesn't increase by 1, it increases by 1 times window width. Is that right? No, that just gives us the same problem we had before. Why is... Man, I've done this a million times, but I'm just being super brain dead right now. Column times 4 plus width plus, I think we need to add the row here. It's going to give us the same result. That's just reversing the... Okay. You can do this. Just stop being stupid. I am assuming that it's just pixels. It is just pixels, right? Oh, man. What? Okay, we've got an out of range exception. So, where is that? Here. because our position went column times 4. Yeah, that's wrong. Column times 4 plus window width times row times 4. Okay, we're just back to exactly the same thing that we just had. I'm going to look at the data. Let's look at the data. Okay. Yes, thank you very much. If we have a look at this. Let's go to this position. All right, here we go. That looks correct. Okay, yeah, we're running red pixels. Okay. I guess I should just put a breakpoint here. So I've written one line of red pixels, and now we're supposed to skip a bunch of them. And let's have a look. Okay, here we are again. Okay. Okay, so I'm pretty sure that we do have just a pixel buffer here, and I'm just doing this incorrectly. Column times 4 plus window width times row times 4. And it would be row plus column. But that would give us the same result. It doesn't matter which way you do this. I'm just going to get rid of that. There we go. Yeah. Okay, let's start with a much smaller, not that one, rectangle, so we can get a bit of a feel for what's going on here. So we'll do a 5 by 8, so 5 across, 8 down. And let's have a look. All right, yeah, so I can see the problem now much more clearly, which is that we move 5 across and then we move down, but we don't move back. So we need to move back to the column that we started at. So I guess we'd say column minus equals width. Look at that. We can draw a rectangle. Excellent. So if we draw a 100 by 300 rectangle, let's have a look. That looks about right, but let's measure it. Oh man, okay. And it's 100 by 291. What the? So interesting. Why? It's got something to do with this? No, we're just putting pixels into the buffer and then sending the whole buffer to the sub-resource, so it's got to have something to do with this. I mean, that's just going to cause an out of bounds right, isn't it? Well, apparently not. Or maybe it did, but I just didn't get an error. Let's have a look. Are we still 291? Yeah, we're still... Oh, now we're 292. Alright, something funky is going on here. Let's make it smaller again. 10 by 20. by 19. Hang on a second. What? Alright, let's have a look. Just make sure that it's actually 10 by 19 and not something weird. I think I've got an idea about what's going on. Yeah, 10 by 19. Alright. So we're supposed to have a 1920 by 1080 back buffer, right? But what we actually get is 1912 by 1049 because Windows doesn't give you the exact size that you asked for. So that was here. So it's supposed to adjust the window rect, right? And we pass in this rectangle, which has window width, window height. Okay. We're supposed to get, well, the correct size window, but we don't have that for some reason, which is very annoying. So what have we got here? Create window at this position, at this size. So this is the problem. I think what's happening is we're seeing a scaled version of the back buffer for some reason. So that's why it's slightly shorter, I think, because it's the width is 1912, so we should be seeing it scaled on the x-axis too, but it's not. Maybe if we make it thicker, we'll see that. So if we make this perhaps 50 pixels wide, and we measure this, .50 pixels wide. Okay. It seems to work on the x-axis, but just not on the y-axis. Or maybe my math is wrong. Could be my math is wrong. Okay, we'll try drawing another rectangle at position 100, 100, and make it 20 by 40. And let's see. by 39. That's kind of telling me that my math is wrong here. But if I make it larger, taller, so it's supposed to be 400, right? Then is it going to be 399 or is it going to be like 391 like before? It's going to be 389. What? Okay. I don't want to just stream a really long debugging session, so I'm going to call that a partial win and say we got a drawing of rectangles on the screen done, which is quite nice, although it's not fully done. There's a bug. I'm going to put a note here. To do, fix, well, let's say rectangle height is not congruent with parameters. Perhaps something to do with back buffer size and window size. Misalignment. Let's see. I'm going to look up something on Google. Win32 client size set. Client size. Exactly. Can we do that? Adjust window rect EX. Oh, his mistake was the following. Okay. So the mistake was that the last parameter needs to be 0. What's the last parameter that we've got? We didn't use the EX version, so I don't think this applies. Can't use WS overlap, but you can use overlapped window. You can call get window rect and get client rect. Let's have a look at those. I just want to see what they came back as. Oops. Client rect. So this will give us a bit of an idea about what's going on, I think. Let's have a look at these parameters. Debug break here. What's the... Yeah, okay. So, where are we? Here. So, window rect. 320 by 1... No, position 320. Oh, God. It's got the absolute offsets. Yeah, client rect. 1912 by 1049. Okay. What? Adjust... There's no adjust client rect, is there? Is there set client rect? Nope. Is there anything else to do with client rect? Get. Okay. What if we do it after the window is created? Hang on. Let's see. Apparently something weird is going on here. Okay, we compiled. There we go. Okay, now I've got a client rect 1912 by 1049 again. What? Oh. That's a weird rectangle. It does add up to 1920 by 1080. No, that's... No, it doesn't. 62. What the? Alright, we're not passing that in, we're passing this one in. Oh yeah, that's what I was looking at. Okay. What is going on there? So. I'm going to stop calling that here. I mean, these would be 0 anyway, so I don't really understand what the problem is. Oh. What? Right, so this is supposed to adjust it to give us a rectangle that would be 1080, 1920 by 1080, right? But that doesn't seem right to me. Let's see if anyone else has figured out how to do this. We're going to discover the actual size of the drawing area and learn a function to more accurately set it. Okay? Thank you, DirectXtutorial.com. Let's have a look. Okay, this is supposed to accurately set it. Right. So, set the size but not the position. Okay, that's what we just did. Overlap window. Okay, we did that. And then we create the window. Yeah, so this is what we had just before. So set the size, which is right and bottom, but we didn't set the position. And then we use, okay, let's try that. We'll try WR right minus WR left and WR bottom minus WR top as this. Except it'll be rect. Right minus left, bottom minus top. Oh, sorry. That was not these ones. Okay. What does that give us? Wow, it worked. We got the right size. Thank you, DirectXtutorial.com. Go, go, go. Okay, interesting. Why does that work? The second parameter is the window style, the third parameter, okay. So I guess I was misunderstanding the point of this. So this is going to adjust this rectangle so that we can use the parameters in here to get the width and the height that we should set for create window to get this size that we want. Why is that confusing? Yeah. Okay. Thank you very much. That's great. Now let's see, did that actually help us with our drawing problem? Was that the issue or was it something else? Let's see, let's see. Whoop, whoop. All right, so this is, ooh, look at that, 20 by 400. That's correct. And 50 by 20. Awesome. So yes, that was the problem. Now, I don't know if you guys have noticed, but when I open it here and I press escape to close, can you see down here it still says running, which means some resource is keeping it open. Something that we've created has to be released. And I'm not sure what it is. It's probably one of these things. swap chain device or device context. So let's see if we can add the cleanup for that before we wrap it up here. So let's have a look. Playback a command. No, we don't want to do that. Okay. So if there is create device, is there destroy device? No. I think there's destroy resource. Something like that. It's not what we're looking for. Let's try the Microsoft search again, see if it gives us anything. Flush. I don't think we want to flush the command buffer. Yeah, why did I even try? Destroy the device and swap chain. Okay, here we go. So it's on the V table. It's just release, I guess. So let's see what we've got. We've got a device context here. So we probably want to do it in the same order that we created it. So we created a device first and a swap chain. So device and a swap chain. And then we created a device context, right? Oh no, that was all at the same time. Okay. So we'll just say device release and pass in the device. And swap chain. Actually, there's probably going to be context first. Let's see if the order matters. Okay, press escape. It's still running. No good. So something else is going to need to get released as well. I think if Daniel's correct, it might be this PP surface. So swap chain. No, there's no release buffer. Maybe I can pass in. Oh no, it has to be this swap chain. Device context maybe? Let's see what this can do. Oh, there's a lot of stuff here. Okay, let's see if there's release. Okay, it only takes a pointer to its own type. Not what we want. Okay. Well, that was not the issue. What else are we making? Don't need to worry about memory. That just gets freed automatically. It's got to be some device resource. I didn't know this was a function that was included in Windows. Zero memory. Expands to memset. Yeah, okay. I'm just going to use memset then. Okay. So let's just comment some things out, stop doing some stuff, and then see if that error goes away. So we won't draw anything. And we won't create pixels. We won't get the buffer. Okay, we've got a black buffer. Press escape. It's still running. Okay, so something here is what I'm going to guess. Just comment that out. got a white buffer, press escape, not running. Okay, so definitely something to do with DirectX, which is kind of what I expected anyway. Okay. So we create all of these things. Run, press escape. Yeah. So there's going to be a function that we aren't calling properly. Let's see. I'll look at D7 Samurai's example again and see if he has anything at the end here. Whoop. No, doesn't look like it. Interesting. I wonder if that means that his thing doesn't get cleaned up properly. I don't know. Okay, that's fine. Let's see what this guy has to say. DX11 tutorial. Real-time message loop. Okay, that's cool. Understanding graphics concepts. This seems like a pretty cool tutorial. Device release. Okay, launching DirectX, yes. Create device and swap chain. Closing. Swap chain release, device context release. So it could be the order that I cleaned it up in. Let's see if that is the problem. Swap chain first, then device. Nope. Swap chain, device context, yeah. Yeah, so this is the problem. If you create a COM object, which is component object model, I think, it's a Windows thing, it will just keep running in the background of the computer. So that's what you can see when I'm pressing close, but it's still running here. So it's still in the task manager. Where is it? It's called debug.exe. You can see it here, just sitting there. And so when I try to compile, it's going to say cannot open debug.exe for writing because it's already open. Pretty annoying. Also, you don't want to release software that just remains open when you close it. That's just not good practice. So let's see. We create a device in a swap chain, yes. We create a window, but we didn't destroy the window. But that didn't matter before. Maybe it matters now? I don't think so. But let's see. Yeah, nope. I'll leave it there anyway. Okay, well, this is kind of a boring problem to stream, so I'm going to leave it there. And just want to thank everyone for tuning in. And let me just open up the thing that we're working on here. So we're working on a software renderer now. We've got rectangles that we can draw, which is great. I am going to figure out this problem off stream. I think it's just a little bit too boring. But I'll tell you what it is at the beginning of next stream. And then we'll work on some rasterization and triangle rendering. So we'll probably do simple shapes and then see if we can move into 3D software rendering, which would be kind of interesting. So yeah, That's it. Thank you very much for tuning in, and see you next time.